To Mathematics, anyone. Today I will teach you the fundamental theorem of calculus. This class is belong to college calculus. I will show you 5 steps to explaining to show you what I mean the fundamental theorem of calculus. Also, after that, I will solve a couple of problems applying this kind of rules. Okay, so welcome to our class or college calculus. Okay, and the first of all, we have this formula. It's our first step. When we have g of x equals integral of a to x of f of t times differential of t, okay, then we have to explain this. If f, for instance, if f is the function is continuous on a b, on a comma b, right? Then the function the function g is defined by g of x, okay, g of x equals integral of a to x, right? F of t, this is t, okay. Differential of t. The rule is when a is equals or is less or equals than x, also less or equals than b. Okay, that's the first actually the first step. For instance, is this kind is continuous. Okay, we have to write it. It's continuous on I told you on a comma b, right? Comma b, and differentiable on a comma b, right? Also this, and g prime of x is equals f of x. Okay, so this is some kind of the beginning how to explain the fundamental theorem of calculus. It is very important that you watch this formula. This formula is very important. So keeping in mind this, and then later you need to review. Just watch the video back. Okay, I will continue. Some proof. We have to talk about the proof of this. Okay, some proof is if in this case, if x and x plus h are in a comma b, so in this space, right? And g prime of x no, let's see. it's right here, period, right there. So if these are right here, so then, yeah, it's period right here. So then there's a conclusion. We will have G, look at this, G of x plus h minus G of x, okay, G of x equals, so now integral a2 here, look at this, is x plus h right here, h plus h, f of t differential of t minus integral, the sine integral a2x, and then f of t differential of t. All right, so right here, so then this will be equals all these. Like to simplify, we will have parentheses right here, open parentheses, and then integral a2x right here of, and then f of t differential of t plus excuse me, plus is if here integral now a2x plus h right here, plus h. All right, f of t differential of t right here equals, close parenthesis here, minus, this is plus, so minus right here, minus integral a2x of f of t differential of t. Okay, this is this property. Remember our last class or college calculus? Let's go back and review. Here, this is apply the property. And number 5, property 5 is right here. Okay, and then ready here. Just watch this step. Let's go one more step. This is a number. This is a proof. Okay. After explaining all process, the theorem, I will show you a couple problems. No worry. Okay. So number 2. We will have. I mean, we have here. In number 2, we have under h right here is but x plus h. Maybe you remember this little formula, right? This is equals 1 divided by h, okay? 1 divided by h, and then integral here, integral x, and then x plus h right there, plus h, f of t differential of t. All right. So we have this step number 2, or I mean the explanation number 2 by property 8. So here by property, we have to review the properties. Last class I show you the properties of integrals. So it's very important. So we have here, we have mh, look at this, mh equals integral, and then x plus h. All right. Of course, f of t differential of t right here, right? Less or equals an m capital letter capital letter M. It's not lower letter. Capital letter right here is very makes the difference right here. So capital letter right there is times H. Right? This here is a lower M letter, lowercase letter, times H. Okay, right here. So this is okay. This that's it. That's it. F prime. This is the derivative of here we have to write UV H less or equals integral. So X right here, X plus H. Of course, here F of T, differential T, right there, less or equals UV times H. Okay. So here, since we have to write it here, since H is greater than 0, H is greater, it must be greater than 0. We are able to divide it. This inequality so this inequality by H. Here, if we divide it by H, we will have F. Oh, this is U, okay? This is F of U less or equals than all this information here, all this formula, G X of H, G of X plus H minus G of X divided by H, okay, less or equals an F of UV. Okay. This is actually this formula is a number when we divide it, this is a number 3. I conclude number 2 and number 3. We are writing to the number 3, okay? Number 3. This case, inequality 3, let me erase it on top, right? This information. So inequality 3 can be proved in a this inequality can prove it in a similar manner for the case H less than 0. Okay, this number 3 inequality. We're talking about number 3, okay? So now let's continue. The whole process is very, very important. So here, so now we let we let that h approach to 0, okay? Then u approach to x, okay? And b approach to x, okay? Since u, because we're talking about u and uv, okay, lay between x and x plus h. Remember, x plus h. Therefore, we will have limit. Use the formula limit of f of u right here when u approach to x. This is equals limit when no, here is when h approach to x to 0, here approach to 0, and then here x, u approach to x, u approach to x, x approach to 0, u approach to x, okay, of limit of f of u, okay. This is equals f of x, and the other one, we will have limit, the other one limit is the uv of f of uv when h approach to 0. This is equals a limit of f of v when uv approach to x equals f of x, okay. So here is already because f, in this case, f when we're talking about f is continuous. F is continuous. So f is continuous at x. All right, that's very important to tell you. So we have, we conclude that three and sequence theorem that after this that we go to the number 4, right? So let's we conclude in this step that and the conclusion here is on 4. This is very important. 4 g prime of x, g prime of x limit when h approach to 0. Yeah, we have here g of x plus h minus g of x divided by h equals f of x. That's a conclusion in this step. So more if for instance, if in this formula if x equals 8, for instance, or b, right, the equation, so the equation for this one, number 4, this one, the equation number 4 can be interpreted or understood as a one side, okay, one side limit. Okay, the theorem 2a4 modified for one side limit. That means that this show, we modified it. We show that G is continuous. Is continuous and A comma B. We using the Leibniz. We using this notation. The Leibniz notation. We use this notation for the derivatives. We can write it also. We can write it F, T, C, and I. Okay, for label and notation. All right. So number 5. After this, I write to the number 5. Let's go to the number 5. I will show you in a problem. Right now it's a 30. It's a 30, but it's important before you know some concept before our class. So now we have the differential divided by the differential of x, integral a to x, f t derivative t equals f of x. Okay, we have right now number 5. So example here we have to find this is the final step on the for the fundamental theorem in calculus. So let me write one example. Let's write one example. Okay. Problem 1 or problem number 1. Find the derivative. Find the derivative of the function let's write the problem here. G of x equals, this is our problem, integral 0 to x, the square root right here, square root of 1 plus t squared, derivative of t. That's our problem. The solution, what is the solution of this problem? It's easy, okay? Just try to make a picture about the theory that I explained before to this. And then also we have to check the properties from the last class, and then in this class, we are able to, so the solution, since f of t here, f of t equals this one, look at this, 1 plus t to the second power is continuous. So this is continuous. So part 1, okay, of the fundamental theorem. Okay, this is the reason. So of calculus. So this is part 1 of the fundamental problem of the calculus that I explained it before. So we have the conclusion of the problem. The solution is g prime, because this is the derivative okay, of x is equals the square root of 1 plus t to the second power. See? That's the solution of the problem. This is the solution. This is the way to solve the problem, okay? It's very easy, though you don't have to think a lot. Just check the information before that I give it to you, and then you arrive to this conclusion, okay? This is problem 1. Let me show you another problem. I will reset everything. If you want to check the information, just looking back the video. Problem number 2. Problem 2. Okay. Number 2, we have to find the d over dx integral 1 2. Here is more difficult. X to the forward power of sec and t, so the derivative t. All right, this is our problem. So what is the solution? I will solve a couple of problems, not many. So it's very simple. Just you need to practice. When you arrive to this class, you must to know a lot of strategies. Okay, remember it's college calculus. This is a very high level of class, but it's not hard. It is very easy. So just follow direction. So the solution here, in this problem here, we have to be careful. Okay, we have to be careful in this problem to use the chains. Use the chains rule. In this case, we have to be careful to use the chains rules in conjunction with the F, D, C, I. Okay, so we have to very be careful. So let in our problem u, I will write u equals x to the 4 power. Okay, then let's go started. So write d over dx. So integral 1 2 x to the 4 power sec t derivative equals d to dx integral 1 u. Just write u. Remember right here in the problem, u sec t differential t. Okay, it's right there. So this is equals. So how conclude this? It will be equals d over du, right? D over du. Let's make a open crochet right here. So integral 1 u right there. Sec t differential t right here inside the crochet. Then times we have to write du d over dx. Okay, here this is a chains rule. Okay, chains rule. So this is equals almost finished. It's equals sec u du divided by d what it says dx. Yeah, dx. Okay, this is by this rule, by f d c I. Okay, here. So this is equals a conclusion. Conclusion is check in parentheses x to the 4 power. Okay, x to the 4 power times 4 x to the third power. All right. That's the solution to this problem. Okay, so let's erase it. Okay, two problems right here. I think that's fine. So now let me. This is the first part of the. This is the first part of the fundamental theorem of the calculus. So the part two of our fundamental theorem of calculus. So the part two is a little bit different. Is continuous. For instance, if f continues on a 0,1, for instance. Okay, now 0, I mean a comma b again, a comma b, right? A comma b. Then we have integral a b. Look at this, a b. Can you see it? A b f of x differential of x. Let me use this another markers equals f. All right, this is better, right? Sorry, so f of a. This is the second part of our problem. Of the fundamental theorem, So where f is any anti f is any antiderivative f, any antiderivative, so of f. Okay, that's it. So the function such as f prime equals f. All right, so how prove this? Let's prove. I will erase this. Let me prove this information that I give it to you. So you wanna see just this part two of the fundamental theorem. So the proof is very important. Number 6. Proof 6 here is f of x equals g of x plus c. So I will to prove this. We will have g of a right here equals integral, of course, a now a to be f of t here derivative equals 0, right? So we are there. So using the equation b with x equals b and x equals 8. All right, we have so we will have f of b minus f of 8, all right, equals open quotation right here, g of b plus c minus g of 8 plus c. Close right the quotient. So this will be equals g of b. We are going to solve some problems. Minus g of 8 equals, g of b minus g of a is equals Yeah, minus u, yeah, g of b minus g8. This will be equals here, yeah, integrals a to b f of t differential t. Yeah, it's the same. The conclusion. So one more here, one more. Let me should be yeah, let me erase this and then I write the last step in this number 6. Just write right here. A to b. This is our formula. So b t. Remember b of t. Here differential t equals s b minus sa. Okay. So example. Let me write the problem number 3, right? We did problem 3 to show so evaluated the integral. So evaluated the integral, this integral 1 to 3 x to the e to the x power differential of x. Okay. So the solution, what is it? How solve the problem? How solve this problem? This is our problem. This one, look at this. Very simple. It is not hard problem. So the function f of x, let's write it. F of x equals, like this. I mean, no, is this is f of x equals integral 1 to 3 e to the x power, okay, is continuous in everywhere. So this is continuous in everywhere. And we know that because remember that is an antiderivative. This is on anti. This must be the condition. Remember the second part of the fundamental theorems. This, we're talking about the antiderivative. Is the antiderivative is f. Just write f of x equals e to the x power. Okay. So part 2. Let's write it. Or the fundamental theorems give us this one. Part 2, the fundamental theorems give us this information. Integral 1 to the third, 1 to 3 e to the x, derivative of x equals f of 3, right? F of 3 minus f of 1, right? F of 1. So this is equals e to the third power minus e. See? That's it. So we often use the notation let me erase it here because I don't have enough space here. Okay. We focus here. So and this we often write the notation so we used to use use this notation. Which one? So f of x, we use like this, a, b. Also, this is equals f b, right, minus f of a. So the question, if also, I mean the equation f d c2 can be written as a integral a b f of x derivative of x equals capital letter F, okay, capital letter F a b. Where here in this case, where f prime is equals f. All right. Another common notation I would like to share with you is this one. So if of x, this is another common notation. The way we write it our problem like this, a b, okay, and also this way, f of x purchase a b. See, this is some notation where I used to work in this kind of problem. Let's see, last problem. Let me solve the last problem. Applying, of course, the Fundamental Theorem of Calculus, part two. So, problem 4. Problem 4, find the area so find the area under under the parabola y equals x to the second power, right? From 0 to 1. Okay, that's our problem. Very simple. Solution. I'll solve the problem step by step. An antiderivative or one antiderivative of f of x, antiderivative equals x to the second power is f capital letter of x, right, equals 1/3 of x. Okay, x to the third power. So this required area area 8 is founded using part 2 or fundamental theorem. Okay, part 2 the fundamental theorem, part 2. Okay, we're talking about that. So the area, so we are looking for the area, right? So area is going to be a is equals mean area. So integral 0 to 1, the integral x to the second power. See here, differential x is equals right here x to the third power divided by 3. Remember the way the notation that I give it to you, the way to write it, just are able to write this, or 0 to 1. So this is equals, first one is 1 to the third power divided by 3 minus 0 to the third power divided by 3. So what is the answer? The answer is 1/3. That's the area, okay? So it's the solution, the problem number 4. So don't forget, today we show you, we learning how apply, how work with, using the fundamental theorem of the calculus, part 1, part 2. So thank you so much. I'm waiting for you to the next class. I hope this class become helpful in some area of the math, especially for calculus.